We're recording. We're recording. So have you guys done linofbstfit before? Linofbstfit. So linofbstfit is just when you have a bunch of data and you organize that data into a table, and then you plot some points and you try to fit the line to that data as best as you can. Whoops, I didn't want to do that. I want to get this. But so when you're fitting a linofbstfit, like some people like to try to connect as many points as you can. That's not really the goal. You want to try to take the average of all the points, right? So kind of the middle. And I taught statistics a couple of years ago, and like there's various software out there that actually could compute the linofbstfit, and the way you actually find the best fit is you kind of take the average distance from all the points, and then they square it, and then they add them all together, and they take the square root of that, and then they find out the best possible line that would be closest to the most of those points. Okay, and it's called the linear regression line. You can kind of see here that this might also, it might be a better fit to do kind of a curve like this, right? Do you think? You know what I mean? Okay, but we're just talking about lines best fit, not curves best fit. Because really, if you look at this and you think about it, this is destination city, distance of that city, and how much it costs for a ticket. This is quite a few years ago. Doesn't seem like it's changed that much. Okay, so here's a linofbstfit. How would I find the equation of that linofbstfit? How would I find the equation? Anyone? What you think? So if I'm trying to put this into the form y equals mx plus b, what would b be? About? Just look.
Like 140.
Yeah, somewhere between 100 and yeah, maybe like 140 or something like that. So you guys know this, right? Y, slope, intercept, and stuff like that. So b might be about 140. So once you make that, you can say that's 140. Now the hard part people have is with the slope, okay? And what I do when I'm trying to find the slope of something like this, I'll try to pick a point that, it's kind of hard on here because I don't have graph paper, but you want to try to, you could either pick 2 points, or you could kind of look at it and approximate where that would go. But what you could do is, I'm going to try to make this dotted, okay? If I want my line tool, I'm going to try to put no arrows on it. We'll make it dotted. No arrows. No arrows. So if I were to go across this way and down this way, and then I do the same thing for this point and this point, you just pick 2 points that somewhere on that linofbstfit. Okay? So I just happen to pick like about 1,000. Do you guys know how to find the slope, which we're actually going to talk about next? How do I find the slope? Change in what over change in what? Change in y over change in x. So it looks like here my change in y, I don't know, it goes from about 180, right? Maybe that's like 180 to about 260 or so, maybe? You with me there? It's hard to see. So maybe this, so what's the difference between 180 and 260? What's the change in y? About 80, okay? What's the change in x from 1,000 to about 2,500? This is just approximate. What? About 1,500, okay? You could reduce this to like 8 over 150. You could reduce that more. Does 4 go into 150? No, but 2 goes in there, right? So you could reduce that to 4 over 75. So that is a good representation of the slope. Are you guys understanding that? Yeah? No? Okay. So I could rewrite like it's not going to be exact, okay? So you get like y equals 4 over 75 x plus 140. Hi.
Hi.
Who's this for? For Elise. Alright. So there's the line of best fit. So the other reason we talk, oops, I'm sorry. The other reason we talk about this a lot, you guys can't see that very well, but is because these types of problems come up all the time on standardized tests, whether you're taking the ACT, the SAT, the PARC test, standardized test. They love line of best fit because it's kind of real life and seeing what you can talk about, okay? Seeing what you know. So the next question I ask you, I'm going to rewrite my equation back up here. Y equals, what was it, 4 over 75x, what did I say, plus 140?
Yeah.
What is the real life meaning of the slope? This is like their favorite question. What does that mean? If this is distance going this way, and this is price going that way, what does that mean in terms of real life? What does that mean? What does a 75 represent over here? Distance. Now what does this mean? And price over here. So for every what? Down here. For every 75 miles, the cost goes up by about how much? $4. So that's what they're looking for by real life. You know what I? So a lot of times they'll ask you, explain the real life meaning of the slope. So the real life, it's not just some number, right? It means like for every $4 or for every 75 miles in distance, the price in that ticket goes up $4. If I divided everything by 4, would that be 37, about $18 per extra mile or something like that, okay? So that's what they're talking about in that question. The next question asks you, I made that do that, isn't that cool? Okay, so the next question will ask you something like, I'm going to have to keep rewriting my equation. Y equals, they always have these same types of questions over and over again. Plus 140. What, use algebra trick, approximately how much a trip to Seattle would cost. And down here, it says Seattle is 2,814 miles away. So how do I do that? You just plug in for what?
For X.
For X. So you would plug that 2,814 miles in for X. So you go 4 over 75 times 2,814 plus 140. I'm going to grab my calculator since I'm lazy. Calculator, I can do this. Did I ever show you my online graphing calculator? Yes? Oh, I did. Well, maybe the other. Okay, so then view, and I move this over. So I have to change this view. Always in front. And so I'm going to go, let's see, 2814. 4 times 2814 divided by 75 equals plus 140. So for Seattle, it would cost me about $290 or somewhere like that. Easy enough? Okay. The other way I could do this, how else could I do this without having to plug into my equation? Go ahead, Ryan.
See like how much further it is than like something like Los Angeles.
Oh yeah, you could do it that way. Like look at Los Angeles and where's Los Angeles? So it's really close to Los Angeles, so somewhere a little bit further. How about graphically? How could I do it? How could I do that graphically? I could just graph the point. I come over here to 2,814 or about 2,000. So this would be, let's see, that's 2,500. This would be 2,750. So 2,800 would probably be about here. Go up to the line and then go across. And it looks like that is somewhere around, I don't know, if I did about 280 or so. So I'm pretty close. See that? So that's another way I could do this. Okay? So that sometimes I'll say do it algebraically, sometimes I'll show on your graph how you can predict. And then the last question, they're asking you backward. Use algebra to predict how far you could travel with $250. Well, graphically, you could come over 250, right? Graphically, this is not algebraically. Graphically, go this way and down this way. So you could go about, what's that, about 2,200 miles or 2,250. If you used algebra, you would plug in for y, right? So you'd have y equals 4 over 75x plus 140. And then you plug in 250 in there. You would subtract 140 from both sides. And you get, what's that, 110 equals 4 over 75x. Did I do that right? Subtracted that. 55. How do I do that? I have to multiply by 75 and divide by 4. I can do that. So I'm going to go 110 times 75 divided by 4 equals $2,062, right? Which is I'm kind of off, But did I not do that right? Yeah, you multiply both sides by 75 over 4. That's what I did with my calculator, right? Multiply by 75 over 4, multiply by 75 over 4. So I did it right, I think I did it right. 75 divided by 4, 2,062. So I was a little bit off, but it's all an approximation. Questions about that? Okay then. You ready to talk about slope? You want to go back to sleep? Okay. Me too. All right, but we're not. I'm just going to do a couple problems on slope. So that's what's next. Okay? And then you'll have time to work. What's this? That's I don't know what that is. Slope. Who can tell me what is slope? What is slope? Give me a definition of slope. Someone, raise their hand. What's slope? Ben?
How much a line goes up or down?
Right. So it's right, how much a line goes up or down. Who can give me a little more formal? You've heard it, Ryan.
Like the rate of the line? Or
Change. It's change in, right? This means change. Change in rise over change in what? Run. You've seen that before. Rise over run. Sometimes they call this delta y over delta x. Sometimes they call it anything else. Anyone know a formula for slope? Well, that m, y equals mx plus b? Why, you guys know that already. Do you guys know why they use the letter m? What else has slope? Where do you go skiing? In the mountains. Comes from the French word for mountains, and that's where the M comes from in slope. Yep, it's true. But, so what if a line's going this way? What kind of slope is that? Decrease. Positive or negative? Negative. That's negative slope. This is positive slope. What kind of slope is this if it goes straight across? It's not no slope, it's zero slope. This, if it goes straight down or straight up, that's called no slope because there's no run, right? It's infinitely steep, right? So the rise would be infinite and the run would be infinitely small, so you would get infinity. So if you get steeper and steeper and steeper, either up or down, that's a no slope. This is zero slope, which is different than no slope because you can have a run, but you don't have no rise, okay? So I would write this next thing down, okay? The slope of a line, okay, you know this, don't you? You can write it down, but there it is, y2 minus y1 over x2 minus x1, okay? And slope becomes like super important when you take, I'm gonna unpause for stationary. Where's my, can I make this work again? Here we go. Watch, am I recording? I'm recording. Whoa! Did you see, wait, I gotta do that again. Watch. Why, I found all these new ways to make things appear on my PowerPoint. So look at this. Whoa! Isn't that cool? Draw the slope triangle and find the slope for AB. Okay? So a slope triangle is something where you draw like a line down this way. Can you see that? And then a line across this way. And you see how much you went up or down. And then you see how much you went across. How much did I go up? Just count the boxes. 1, 2, 3, 4, 5, right? So 5 up. Oops, I need my tool. Which one? This one? 5 up. How many did I go? We need a better color. 5 up. That's not. Come on. 5. 5. How many did I go across? 1, 2, 3, 4. So what's my slope? 5 rise over run, 5 over 4. And whenever you're measuring slope, the rise over run is always from left to right. So if it goes uphill from left to right, positive. If it goes downhill from left to right, it's negative. Can I move on to the next and final slide?
Yes.
Okay. So so next thing says find the slope between 2 points. So all you'd have to do, I would use the formula y2 minus y1. So if I call this x2 and this y2, then I call this x1 and this y2. It really doesn't matter which one you call x1 and y1 and x2 and y2, you'll get the same answer. I would go with the first one first and the second one second. But what you can't do is mix and match. You can't say this is x1 and this is y2, right? So this has to be either you call this x1 and y1 or you call it x2 and y2. Those two coordinates have to go be the same. So we're just going to do it -5 minus 7 over 2 minus -3. I threw in some negative numbers there to make it confusing. -12 over 5. That's your slope. Yes? Easy enough. You've done that before. I know this is algebra and stuff, but it's a good review. Okay? Can I move on?
Yeah.
Okay. So, and then the very last thing says, so this is where it gets a little tricky. Given that a line has a slope of -5, 3, and goes through the point 5y, and -1, 8, find the value of y. Because there's a couple problems in your homework like this. And so what you have to do is set up an equation, okay? So you just, you know that the slope, right? Slope is equal to -5 over 3. And you know that that's equal to, I'd call this y2 and this x2, right? x2, that's a y, not a y. y2 and that x2, and call this x1 and y1. So you could set up a little equation that says you have 8 minus y equals -1 minus 5. Follow what I just did? Okay? So this is, because people get very confused by this problem. And then I would simplify this. I get -5 over 3 equals 8 minus y over what? -6. How do I get rid of the -6 in the denominator? Multiply both sides by -6. Okay? Multiply both sides by -6. And that gives me 30 divided by 3. Oh, that's easy, right? What's 30 divided by 3? 10 equals, those cancel out, right? 8 minus y. So y equals, bring it over to that side, -2. I'm not going to do the algebra there, but that's the answer. Y equals -2. So that's about as tricky as it gets. And it asks you some problems about real life stuff and junk like that. And I think that's it. So now, do you want me to go back? Anyone want to copy that down? Oh, sorry. Okay. Going back. Whoops. Going back. Where'd I go? Can you see that? That one. I'm going to pause for station identification. This is Mr. Leader's mouth channel. Okay.